Alright, Algebra 2. Okay, we're skipping up here to Chapter 9. We're going to look at a couple sections up here dealing with sequences and series. 9.1 though starts talking about mathematical patterns. Okay, want to get a couple of terms identified here that'll help us when we get into some of these other sections. Our essential question is, what is a sequence? Okay, so that's what we're going to answer first. A sequence is an ordered list of numbers. Each number in a sequence is a term in the sequence. So when I list out some numbers here, the first term that I list will be A1, first term. The second number in the list will be A2, and then so on until we get to an nth number, and then the one after that would be n plus 1. You'll see where that comes into play. The one before that one would be a to the n minus 1. But it looks like this. Okay. We're going to look at two terms. The first one is the explicit formula, and it describes the nth term in a series using a number n. We're going to have an n in the equation to identify how to find these numbers, okay, what the pattern is. So if I have the pattern 2, 4, 6, 8, 10, dot, 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 out to an, the nth term, then 2 is the first term, 4 is the second term, 6 is the third term, and so on. You can see it as it goes. Okay, so what I'm looking for here is the pattern. Okay, when I look at the first term, I got 2. My second term was 4. And my third term was 6. So I'm looking for a pattern here, and I see that when I take my n value, first term, and I multiply by 2, I get 2. When I take my second n value of 2, 2 times 2 is 4. So what I'm doing is I'm taking my whatever term it is, and I'm multiplying it by 2, and I'm getting that number. Like here, the fifth term, 2 times 5 is 10. The fourth term, 4 times 2 is 8. So there's my explicit formula right there. If I want to know what's the 100th term in this series or sequence here, it would be the 100th term. It would be 2 times 100. The number would be 200. Okay? So if I wanted to string those out, so I had 100 terms, that 100th term would be 200, would be the number 200. Okay? Another look at explicit formula. Here I'm giving you the explicit formula. Notice the n in the equation. It's saying the nth term is equal to 3n minus 2. So write the first 10 terms. Alright. Well, the first term would be a to the 1. So now n is 1. So I plug in 1 for n in my equation there. 3 times 1 minus 2 is 1. n is 2. 3 times 2 minus 2 is 4. The third term, 3 times 3 minus 2 is 7. All the way down to the 10th term, 3 times 10 is 30 minus 2 is 28. So there they all are strung out there. You can see there's 10 terms right there. Okay? Explicit formula has an n in the equation for it. And basically you're identifying the pattern as to how to find each term, usually based on the whichever term it is. Okay? You'll see that tomorrow when we start looking at some more examples. Alright. Now let's look at a recursive formula. A recursive formula relates each term to the one before it. So I have to know the one before it. You want to know what the second term is? You have to know the first term first. So they're always going to give you the first term. Okay? Like here. You want to know what the nth term is? You take the one before it and subtract 3. And of course, n has got to be greater than 1. Okay? You can't say, give me the first term and then try to find the 0 term where there isn't. Okay? You'll start here with 2, and then you'll take the first term minus 3, and that's how you get the second term. And you can see that here. Write the recursive formula. This is example 2 on page 586. They're showing you a series of blocks. There's one block, and then there's 3 blocks stacked up, and then there's a stack of 6 blocks, and a stack of 10 blocks, and 15 and 21. Okay? So there's my first term, my second, my third, my fourth, my fifth, and my sixth. So since a recursive term relates to the one before it, I start with 2 because I got to start with n greater than 1. Right? So I start with 2 and I subtract the term before it. What do I get? 3 minus 1 is 2. So the difference here is 2. Third term minus the second term, 6 minus 3 is 3. The fourth term minus the 3. And I just carry this out each time. 2 minus 1, 3 minus 2. And this is the term number. Okay? And I get 4. And you can see the pattern that's developing here. 2, 3, 4, 5, 6. It's going up by 2, going up by 3, going up by 4, going up by 5, going up by 6. Okay? So when I take the nth term and I subtract the term before it, I get n. Notice here, when n is 2, I got 2. When n is 3, I got 3. When n is 4, I got 4. When n is 5, I got 5. When n is 6, I got 6. So I want to know the nth term, take the one before it, and I get that n. Okay? Add over the a to the n minus 1. So my recursive formula is the nth term is equal to the n minus 1 term, the one before it, plus n. Okay? So that's a recursive. Notice it has the term before it. Relates to each one before it. So I got to have the a to the n minus 1 in it. So you'll usually see it as there's the first term, and then each successive term is just taking n minus 1, whatever that term was, and adding n to it in this case. Okay? This one gets a little tricky at first. Once you start doing some examples with it, you start to see how it works. Okay? So we had the explicit formula. You have n in the formula, whatever term n you're looking for. The recursive formula, you have to know the term before it. Okay? To find the current one. You want to know the fifth term, you got to know the fourth term. Not true with an explicit. You want to know the 200th term, just plug 200 in for n and you can figure it out. Okay? Here you always have to know the one before it. So those are the two different types. Okay? Sequence, just a list of numbers. We're looking for the patterns in them. This is two ways to do it. Okay? Tomorrow we'll start working on it in class and we'll go from there. Alright, see you then. Bye.